Welcome to 90 Notes. We're going to have a look at 5 perpendicular theorems that appear in section 3.6 of our textbook. You know, the one that looks like that. So get this out of the way. We're going to say, hey, theorem 3.8 here says that if we've got two lines intersecting to form a linear pair of congruent angles, I guess the lines are perpendicular. And that makes sense. You know, you can almost see the proof in your head saying, well, two angles are a linear pair. They're supplementary. They add to 180. They're congruent. They add to 180. They must be 90 each. That just about writes itself. Honestly, I don't know that I've used this one a lot, but it's there. 3.9. Two lines are perpendicular. They intersect to form 4 right angles. I like that. Honestly, in proofs a lot, I'll use definition, perpendicular. Two lines are perpendicular, then they form right angles. So either way. So I got to admit, I don't think I've used this one a whole lot in proofs. How about this one? 310. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Wow. That's kind of cute. I've used this more when I'm and the kind of problems you're going to see coming up, more in those algebra type problems, solve for the other acute angle. But I don't know that I've used it in proofs a whole lot either. Here we go. Now, 11 and 12, 311, 312. If a transversal is perpendicular to one of two parallel lines, well, then I guess it's perpendicular to the other one. Now, that makes sense. Now, notice they don't have to say anything about being coplanar, since parallel lines are, of course, by definition, they are coplanar. So we've got these two, two parallel lines. Transversal is perpendicular to one, perpendicular to the other. How about the converse of that? Well, 312 says, they left something off in the textbook. I am going to add this in the same plane. Because two lines are perpendicular to the same line, then they are parallel. Well, I'm going to show you when they're not. Imagine if I take K and think 3D and I rotate it towards myself. See, now H and K are both perpendicular to J, but H and K are skewed to each other in different planes. So I would qualify this statement with this little phrase, in the same plane. They're both perpendicular to the same line, then I guess they're parallel. And let's do a proof of that one too. That's one of the exercises. So some of the exercises here, and this is in our textbook, number 3. 4 and 5 are complementary. How do we know that? Well, we just saw that. There's theorem 3.9. You see, we might use this theorem to justify a statement or justify something, and maybe we're going to set up the measure of angle 4 plus the measure of angle 5 is equal to 90. How about number 5? Applying the theorems. And again, we've got the same theorem. These two, while they are, I like to say that they are complementary adjacent angles. I think that's a nicer way to say it, but to each their own. And of course, we could use that to solve for the measure of angle 1. These two angles would have to combine to make a right angle. How about 7? Well, we've got our perpendicular lines. They form 4 right angles. And of course, that one would be 52. Makes sense to me. Now, this is really getting pretty easy. Hey, what's wrong with this picture? I love these error analysis questions in your textbook. They're saying, well, if this perpendicular here, y and y must be parallel to z. And we say no, because nobody said that the line y was parallel to x. Or I'm sorry, perpendicular to x. So since there's no mark indicating y perpendicular to x, then y is not parallel to z. Tricky. All right. How about this? What's wrong with this? The distance from AB to the point C is 12 centimeters. And it just plain can't be, because we learned that, well, the distance between a point and a straight object is by its definition the perpendicular distance. And perpendicular is not 60 degrees. We could visualize it like that. So we know that there exists some distance between C and the line AB, which is shorter. So 12 centimeters is not it. Like that. How about 15? Now we're getting somewhere. Again, with our, gosh, we're using that perpendicular lines. They form 4 right angles. Yeah. So now we're going to set something up. Let's say, well, I've got this plus this equals 90. Now the algebra is not so hard. I mean, you could just, I might group this so I can say that this angle is 27, and then solve for x, subtract the 14, and we're good. Easy squeezy. How about 16? What are we going to do here? Perpendicular lines form right angles. So we've got this. We've got these two angles, have to combine to 90. I guess x is 95. All right, just a little bit more. Told you we'd get through this quickly. How about this one? I've got here, again, perpendicular lines form right angles. And it forms 4 right angles, but we only need this one. So I'm going to add this and this. And I'm going to say that equals 90. And work it all out. X is 33. Okay, how about something a little different? Let's just fill in the blanks here. What do we got for angle measures? Well, it's kind of fun. We've got the perpendicular lines here. That means I've got 4 right angles. So that means that angle 5 must also be 90, because of course angle 1 and angle 5 are 90. We can also say this perpendicular sign gives me 90, and these two are vertical. So angles 1 and 5 are going to be 90 degrees. And over here I've got adjacent complementary, so 2 must be 60 degrees. And what else we got there? Well, oh yeah, we've got, again, vertical angles right there. So there's my 30. And now I've got these 3 angles which have to combine to make 90. Well, that was kind of fun. All right, one more thing, and it's the proof. You'll like this proof of Theorem 312. The lines perpendicular to a transversal theorem. Now, I added that part. This is in your textbook, number 34. And they were saying, given that line A is perpendicular to T and B is perpendicular to T, I added the coplanar part, because otherwise I don't think it works. So you've got these lines, these 2 pair of perpendicular lines, and we've got the 3 lines are coplanar. I'm going to say that angles 1 and 2 are right angles. And I know that. I could use a definition, or I could use my new theorem that perpendicular lines intersect to form 4 right angles. That's our new theorem 3.9. Or I could just use the definition. And then I've got this. Angle 1 is congruent to angle 2. We had a theorem a long time ago. If 2 angles are right angles, then they are congruent. Pretty nice. Now, if you look at this, what position are they in? They're in the corresponding position. So that would be the, well, that's the converse of the corresponding angles postulate. So A is parallel to B, because postulate 16, which is the converse, the corresponding angles postulate says, in my very abbreviated shorthand, if 2 lines are crossed by a transversal such that corresponding angles are congruent, then the lines are parallel. And there you have it. That's the proof of the day. And let me say thank you for watching 90 Notes.